7 cm tall pencil is placed 35 cm from a thin, converging lens of focal length 25 cm. What are the nature, size, and location of the image formed? Okay, well, let's sketch the situation that we're talking about first. So we'll draw in an optic axis and we'll put the lens at that position. That's supposed to be a straight line, of course, and we'll mark the focal point and 2 times the focal point on both sides. And you will remember that the 2 times the focal point is an important length in the optics of thin lenses, in exactly the same way that the radius of curvature is an important point in the center of curvature, is an important point in considering the optics of spherical mirrors. So we're told a 7 cm tall pencil is placed 35 centimeters from a thin converging lens of focal length 25 centimeters. So f is 25 centimeters, 2f is 50 centimeters, and our object is placed 35 centimeters away. So let that be our object with an arrowhead at the top. And it happens to be a pencil, which will be roughly pointed anyway. So we can consider the 2 principal rays for a thin lens. One is parallel to the optic axis, and rays which are parallel are refracted such that they pass through the focus of the lens. Oops, that was spectacularly poor. Let's try that again. Slightly better. That's supposed to be passing through the focal point. And the other principal ray for a thin lens system is that which passes through the center of the lens, which does so undeviated. So where those 2 rays meet will be where the object is formed. It will be a real object, that is, it could be projected on a screen, and it will be inverted. Okay. So we're asked for the nature, size, and location. So by location, we mean what is the distance of the image. That distance is q. And similarly, the object distance, p, we were given as 35 centimeters. So we use exactly the same equation for thin lenses and spherical mirrors. The reciprocal of the focal length is equal to the reciprocal of the object distance plus the reciprocal of the image distance. So we wish to know q. So subtracting 1 over p from both sides, we have 1 over f minus 1 over p equals 1 over q. And by direct calculation then, we can find 1 over f is 1 over 25 minus 1 over 35, which is minus 0.01142 is 1 over q, and therefore q is 1 over that. Q is equal to minus 87 0.5 centimeters. And I can see that I must have made a mistake because I have a negative number for Q, and Q must be a positive number. So going back and checking using reasonableness, 1 over 25 is going to be a bigger number than 1 over 35, and therefore I have made a mistake, and I'll recalculate that. And when I do recalculate, I find this should have been plus and plus. So Q is 87.5 centimeters. Fine. So I'm going to remove most of the information so that I can carry on without deleting the diagram. Okay, so that is one of the answers that we require, so let's take a note of that. Q is 87.5. So we have answered the nature, it is real, the location, it's at 87.5 centimeters beyond the lens, but what we haven't answered is the size, and therefore we need to use the magnification equation, and the magnification equation is the size of the image over the original size, and the magnification is given by minus Q over P. So the magnification is minus 87.5 divided by P, which is 35 centimeters. And I've been naughty, but the units will cancel. So the magnification is given by minus 2.5. The negative sign tells us that the image is inverted, which we already knew from our ray diagram. So that's an intermediate result, which is useful, but the negative sign tells us inverted, which is the part of the nature of the object. Sorry, of the image formed. And lastly, therefore, we need to calculate the size, and if the magnification is 2.5 and the original size was 7 centimeters, then 7 centimeters times minus 2.5 gives us minus 17.5 centimeters. So let's actually answer the question. The nature of the image is real, inverted. The size is 17.5, let's be correct, minus 17.5 centimeters, located 87.5 centimeters beyond the lens. And that's our final answer. So as always, we'll do something to help the poor person who needs to mark to work out what we've actually done. And we can be very confident that we haven't made a mistake in this problem because we drew the ray diagram. If we had not drawn the ray diagram, we might be slightly less confident and we would want to check our numbers, which is always a good idea. And we're done.